All right, in this problem, they're asking us to find the tangent of A plus B. If I knew what A and B were, I would just add them together, take the tangent, and be done with the problem. But I don't know what A and B are. They weren't given to me in the problem. And so what I'm going to use is the formula for tangent of A plus B. This is the one from the 17th century that we've talked about in our trig identity topics. So I'm taking this formula here. What I'm going to do is I'm going to find the tangent of A and the tangent of B. If I could find the tangent of A and I could find the tangent of B, then I could compute this quantity. Let's start with the tangent of A. They didn't give me the tangent of A, but what they did give me was the sine of A. Now, I also know that for any arc length A, cosine squared plus sine squared equals 1. And so, if that's true, I can plug in the sine value that they gave me and do the algebra. After some ugly algebra, you'll see that the cosine of A is plus or minus 4/5. Algebra not shown. However, we were also told that A is in quadrant 1, and so therefore the cosine would be positive, and now I know what the cosine of A is. But wait, wasn't my goal here to find the tangent of A? Well, now that I know the cosine of A, and I already knew the sine of A, I can compute the tangent of A by just doing sine divided by cosine. When you do the math on that, work not shown, we do end up with the value for the tangent of A. And in some sense, now I'm half done with the problem because I have the tangent of A. I now need to find the tangent of B. Well, they didn't tell me the tangent of B, but they did tell me the cosine of B. And knowing that cosine squared plus sine squared always equals 1 allows me to make an equation by substitution that will give me the sine of B. Just like before, some ugly algebra will show that the sine of B is plus or minus 12/13. B was also reported to be terminal in quadrant 1, and therefore the sign would be positive 12/13. Now that I know the sine of B, and given the fact that I already knew the cosine of B, I can compute the tangent of B by doing sine divided by cosine. Sine divided by cosine works out to, algebra not shown, 12/5. And that completes the second portion of this problem. I now know the tangent of A and the tangent of B. But remember, I want to know the tangent of A plus B, and therefore decided to use this formula to get it. All I have to do now is plug in what I know for the tangent of A and plug in what I know for the tangent of B, and all I've got now is one big ugly fraction mess. I've shown you some of the work here, not all of it. If you want to hit pause and examine it, you can. Otherwise, suffice it to say that the answer is negative 63/16 for this first part of this problem. This problem also asked us in additional parts, is it possible that A is greater than 1? And is it possible that A plus B is greater than 5? Well, I want to remind you that we were never told what A specifically is or what B specifically is. But the answer to both of these questions is yes, and let me explain why. We were told that the sine of A and the cosine of B were certain numbers, meaning that they indicate some possible terminal points on the unit circle. But remember, we'll take A as an example. Any point that terminates with a y coordinate of 3/5 has a sine value of 3/5. So A could literally be any arc that terminates at either of the points whose sine or y coordinate on the unit circle is 3/5. And there are infinitely many arcs that can terminate there, and they can be as big as we want. A could be up in the millions if I wanted it to be, because I could wrap around the unit circle many, 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 many times and terminate at a point whose y-coordinate is 3/5, thus satisfying the condition for A. So if A could be up in the millions and beyond, isn't it possible that it's greater than 1? Of course. And the same logic applies to the next question, A plus B is greater than 3. Of course that's possible if, by my logic, A and B can be in the millions. They can certainly add up to something greater than 3, of course. And that's the first problem on this assignment.